Hey everyone, so in this video we'll be talking about rectangular matrices. Now if you're not familiar with what a matrix is, then please check out our previous video where we talk about what a matrix is, and we also go over basic matrix notation, the order of a matrix, what an element of a matrix is, and so on. So please check that out if you're not familiar with the basics of what a matrix is. Now moving on to what we're going to cover here. So in this screen you see three different matrices. So the first one here, you see it's got 3 rows and 1 column. The second one here is 1 row and 1, 2, 3, 4 columns. And the third matrix here has got 1, 2, 3 rows and 1, 2, 3, 4 columns, right? So now what's common between these matrices? You see that each of these matrices, right, has different number of rows to number of columns, right? So the number of rows is not equal to the number of columns for any of these matrices, and these are called rectangular matrices, right? And if you remember geometry, a rectangle, the adjacent sides are not equal. So you look at these and you can clearly see they look like rectangles, but the actual reason here is that the number of rows is not equal to the number of columns. So I've just shown that matrix here again, and you can see it's got 3 rows and 4 columns. So it's a rectangular matrix. Now looking at more general notation, you see here the first row here in this matrix starting from A11, first row, first column. So the first element is the row index, the first subscript is the row index, and the second one is the column index. And you go to A12 all the way to A1n. So that tells you there are n columns. And now looking down at the rows, you have A11, then you have A21, then you have A31 all the way to AM1. So you have m rows, order m by n. And so for a rectangular matrix, right, for a matrix A, in this case I'm just calling it A, Aij m cross n, the I, which is the row index, goes from 1 to m, and j, which is the column index, goes from 1 to n. And for a rectangular matrix, m is not equal to n. So the number of rows is not equal to the number of columns, right? It's a very simple concept, right? That's it. That's as simple as it is. Okay. So now let's look at a different kind of matrix that is also a rectangular matrix. You have a column matrix. So now what do you see here with the column matrix? You see that it has got 3 rows and 1 column, right? And so it looks like a column of numbers. So that's what a column matrix is. So looking at a more general version of the column matrix, you see here that the matrix has m rows, and so it goes from A11, A21 all the way to AM1, and it has only 1 column. The column index is the same, it's 1. And the order of the matrix, you've probably already predicted this, is order m cross 1. So for a column matrix, the matrix A, Aij, m cross 1, the I, which is the row, goes from 1 to m. J is always 1, right? Because it's only 1 column. Okay. So if you see the column matrix here, you can guess what the next one will be. It's a row matrix, right? And so it's just a matrix that's just 1 row. And it can have many columns. In this case, there are 4 columns, right? And you can see it looks like a column, right? So very easy to identify. So a more general case where you have 1 row, but you have n columns, right? So the elements go from A11, A12 all the way to A1n. And the order is 1 by n. So again, writing it in normal matrix notation, Aij 1 cross n, where now the I or the row index is the same. It's, you see all of them, the row index is 1. The column index goes from 1 to n. Okay. Now a different kind of matrix that you see here, and it's a fairly important matrix, is a zero matrix. Now you'll see where this is used as you start understanding identities of matrix addition and multiplication and so on. But a zero matrix, as the name suggests, is a matrix full of zeros, right? It's also called a null matrix. So every element of the matrix is 0. So Aij, which are the elements of the matrix, are 0 no matter what the I, no matter what the j, right? So that's very simple. So the I and j can be anything, and the matrix can have whatever order it has, but it's all the elements is 0. Okay. So now let's give you a few examples and see if you've understood the concepts. Start with the first one. Can you identify this matrix, right? What kind of matrix is it? So very simple. You look at it and geometry itself tells you, but just looking at it, you can say what it is. But it's got one row, it's got two columns. So one row is the key. It's a row matrix. Okay. Next one. So again, it's got four rows, but the key, it's got one column. So it's a column matrix, right? Very simple. Look at the third one and you go, okay, it's got three rows, two columns. So it's not a row matrix, it's not a column matrix, but the number of rows is not equal to the number of columns. So it's a rectangular matrix. Simple, right? Now, in a different video, we'll cover square matrices, and so you'll really see the difference, right? But hopefully this is very clear to you. So now, to kind of cement your concepts a little more and to make sure you've understood this clearly, please take a quick test on TeachYaar.com. It's a free test, and I've dropped a screenshot of the test here. To take the test, you can scan the QR code on your mobile device, or you can click this link, and we've dropped this link in the comment section. We've also dropped it in the description section. So you can take the test, and at the end of the test, you'll get the solutions. You'll also get some feedback or learning about this topic. So please do the test, and please subscribe to the TeachYaar YouTube channel so you can get notifications when we add more content.